Okay, today we're talking about graphing exponential functions. To be able to do this well, you're going to be needing your graphing capabilities, not on your calculator though. We're going to be doing this on the iPad. It's going to be kind of cool. There's an app I'm going to show you. I checked on my iPad, it worked fine, so we'll find out if it'll work well for you or not. All right, so everybody get to this page in your notes right now and turn it my way so I can know you are with me. Pause for a second while I'm waiting for... All right, here we go. So, to be able to do exponentials, you have to understand that you're just moving them like you would any other function. So I'm going to go to the side for a second and say, do you remember when we had x squared and we did this to it? Where does it move? Look up here, please. It's not in your notes. It's up here. Okay, this is up 7. How about if I put a 2 in front? What does that do? Twice as tall. Twice as tall. 2 times taller. That's called a vertical stretch with factor 2. Okay, what if I put a minus 1 in there? Which way is it going to move now? Right 1. Okay. And does the order matter? Yes, it does. The order matters. Order matters. That's back to permutations, yes. Anyway, the order matters. You would start on the inside and do what's inside first, because inside the parentheses has priority. Now, actually, there's more than one way to do this, but this is my favorite way. You start on the inside. Once you're done on the inside, you go to the outside. When you're on the outside, you follow the normal order of operations. So multiply comes before add, right? So this would be first. This would be second. This would be third thing that you should do. Does that make sense to you? You start on the inside just like you normally would with a heavy-duty math problem. And then once you're done with the stuff on the inside, you go to the outside, and these are the 2 outside things. And which one should be first? It follows the logical order when you're on the outside. What if you're on the inside and there's 2 things to do? Let's say we had this. Okay, that one has 2 things to do on the inside. You start in here, but which of them should you do? You do them in the opposite of normal order. Okay, so shut your iPads. Some of you are screwing around. I hate to make everybody stop, but I need your full attention. Okay, so if I'm on the inside here, look up at the board now, please. Thank you. If you're on the inside, which of them would normally be first? Multiply or subtract? What's normally first? Normally first is multiply. Multiply comes before subtract. But since you're on the inside, it's the opposite of normal. And therefore, that is first. Do you understand that logic? But please excuse my dear Aunt Sally, tells you the normal order. And multiply comes before subtract. Here's the multiply, here's the subtract. Multiply comes way before subtract. Do you get that? That's the normal order of things. Okay, so this is normally first and this is normally second. But when you're on the inside, it's the opposite of normal order. And therefore, this is actually first and this is actually second. It's the opposite of the normal order. Do you understand that now? All right, I'm seeing a few nods. All right, go back to your notes and get it to this yellow screen right here. We need to know what the parent function looks like before we can start sliding it around, moving it left or right or up or down. So everybody get to desmos.com, www.desmos.com. I'm going to pause for a second while you do that, and I'm going to try to get it on my computer here. It'll look a little different than on the iPad, but that's all right. Okay, so you want to hit the Launch Calculator button, and then it'll look like this. Except yours will be probably prettier than mine because it's on an iPad. Now, if you wanted to graph those things, this is going to be tricky to go back and forth, but I'll try. You want to graph 2 to the x, 3 to the x, 4 to the x, and 5 to the x, and make them different colors. Use a different color for each graph. You got to use the A to the B button. The A to the B button is the one that will get you a power. Okay, so I'll try to demo that here. You're doing 2, 3, 4, and 5. All right, so I'm going to go 2 to the power of x. There it is. The power of button was the A to the B button. And now, how do you move down? Has anybody figured that out? To do another one. Is it plus? Or would enter work? Oh, enter works. Okay. Cool. Then I'm going to go 3 to the x. Automatically did a different color, right? Did yours automatically do difference? Okay, good. So graph all of them. And then what I want you to do is try to see what the difference is. Every time you make one with a bigger base, I think you're noticing something. All right. How about this? Would you agree that it got steeper every time you had a bigger base? All right. Let's test that. How could we make it get not as steep? Okay, so what's smaller than 2? All right. Let's try 1 to the x. Did it do what you expected? Straight line. Well, what's between 1 to the x and 2 to the x? Yeah, 1.5 to the x. 1.5 to the x. Ooh, there. See how we could get an infinite number of these things? 1.6 would be a little steeper. 1.7 would be a little steeper. 1.2 wouldn't be very steep at all. Okay, I think you're getting the idea. And how about this? What point did every single one of them go through? And I want you to think about that. Why would they all have to go through 1 at that spot? Yes, sir? When it's to the power of 0, they all have to equal 1, right? When any one of these puts power of 0 there, so if x is 0, it'll force everything to the power of 0, which makes it equal 1. Good observation, sir. All right, so now let's compare that to the next slide I have here is all of these. 1/2, 1/3, 1/4, 1/5. Now you got to see if it like does the same kind of a deal or not. 1/2 to the x. Everybody graph 1/2 to the x. Now, do you know how to clear off your Desmos? Yep, you can click the x and it'll delete your functions. So I'd recommend you delete all of these so you can just clean it off. Okay, now I'd put it in parentheses. I don't think it will work if you don't put it in parentheses. 1 divided by 2 in parentheses to the power of, I got to get out of there. Arrow over. To the power of x. And something went terribly wrong there. There we go. I got it. Look at that. It's completely flipped. It's almost like you did a flip of it. Now, if you think about it, there's a logical reason why we did a flip about it. Yes, sir?
Well, I was going to say why.
Tell me why.
Because fractions are the flips and exponentials.
Yep. They are the flip of whole numbers. So 2 compared to 1/2 is a flip. How do you show that in an exponent when you want to flip something? So you're saying that 2 to the negative 1 x would actually be 1/2, wouldn't it? Do you get that this 2 to the negative 1x is like, look at this, it's like 2 to the x, except they put a negative right there. Do you get that that would flip it left, right? That makes sense to you? If I stick in a negative right there, shouldn't that make my function flip left, right? It does. And by putting in a negative there, you got a 2 to the negative 1 right there, which really means you have a 1/2 right there. So wherever you see 1/2, couldn't you be thinking of it as like 2 to the negative 1? That is what 1/2 is, to the x. And that's just exactly like 2 to the x with a flip built in. All right, if that didn't make any sense to you at all you need to know is that these are decay, and so they go down as you go from left to right. See, this is going down, lower and lower. And all fractions are going to do that. Okay, so let's graph a couple more. Put in 1/3 to the x on yours and 1/4 to the x. Oh, that extra parenthesis messed me up. There we go. To the x. So, is 1/3 bigger or smaller decimal? Is 1/3 a bigger or smaller decimal? That's smaller. So you see the red one compared to the black one? So if it's a smaller decimal, it what? It's steeper. So let's like make a ridiculously steep one. Okay. 1/15, did you say? Well, okay. Go big or go home, I guess. 1/50 to the x. All right. Of course, that makes me want to make it even more ridiculous. So 1/500. Ooh, it instantly graphs it. 1/5,000. 500,000. All right, so do you get how it's still going through 0 though? Or sorry, going through 1? Because when you put anything to the 0 power, it equals 1, right? All right. Okay. Good enough. I think you got the feeling from playing around with your iPad here of how these things work. Now, I just want to remind you, if you have a problem like this and you have an A in front of it, that is a vertical stretch. What if A is small, though? Like, what if I put a 1/2 right here? Get to this screen on your iPad, please. What if I put a 1/2 right here? Then it would not be a vertical stretch. It would be a vertical shrink. Factor what? Come on. What's the factor? That's the factor. The factor is 1/2. It's a vertical shrink factor of 1/2. Okay, how about if I change this to y equals 3 to the 2b to the x minus 5 plus 7. You should be able to tell me what all these things did to my plain old-fashioned 2 to the x that it would have been. No, b to the x, sorry. And b could be almost anything. Let's say b is like, was going to be 2 to the x. So this is kind of like your parent function, 2 to the x. You should remember that they always look like this. Just how steep they are is the only difference between them. They always go through 1. Okay. So then what are all these changes? What does this 2 right there do? Be careful. It's on the inside, so it's counterintuitive. It makes it not as wide. It makes it narrower. Because normally you'd think it would make it wider, twice as wide. It in fact does half as wide. So that is called a horizontal what? Shrink. And that 2, would you use a horizontal shrink factor 2? No. Shrinks use fractions. So this one right here stands for horizontal shrink factor of 1/2. Okay? What would that one stand for? Vertical stretch factor 3. Good. How about that guy right there? It just goes which way, left or right? Right 5. That's it. How about this plus 7? Up 7. We can get fancy and say that it's a horizontal translation, but it's a lot simpler to say left 7. All right, good enough on that. Everybody get to this one. If you have to graph them by hand, which you do, there'll be some problems where you can, actually I'm not even positive we're allowing the calculator at all. So you need to know how to graph these puppies by hand. Your best friend is the XY chart. I think I've told you this before. In fact, I know I've told you before. I just think you'll remember that I told you before. That the XY chart helps you with any kind of graph you ever make from now until the rest of time. You can always make an XY chart. It's just a list of points, and then you get to play connect the dots. That's all. So let's pick some points that are on here. Well, you can pick anything you want for X, anything. But you might want to start with something simple because you don't want to have to like figure out something complicated. So why don't we pick X as 0? If we put in a 0 right there, that'll be, here's a really common misunderstanding. People think, oh, so the whole thing turns into 1 because it has a power of 0. No, only this part right here turns into a 1. When I do 3 to the 0 power, that'll be 1. And then 2 times the 1 makes 2. 0, 2 is on your list. Make a list for me. And how many points do you have to have? 4 to 5 of them. Kind of depends. Why 4 to 5? Because sometimes you aren't going to be able to put all of those on there. In other words, they won't all fit. If you put in a 1, that'd be the next logical thing if you haven't already got that in there. Did you get, when you put in a 1 right here, did you get 3 times 2 is 6? Raise your hand if you had that right. Okay, good. On to the next couple. Put in a 2, and I got 6 times 2 is 12. And then that's going to start getting too big, isn't it? Oh, wait a minute. Sorry, I put in a 2 and I tried to do it in my head quick. 3 squared is 9 times 2 is 18. Okay, sorry. Too big. So then let's go down and get a smaller number. Well, let's see. 2 is too big. 1, 0. How about negative 1? That'll be interesting. Do you know what negative 1 power does? 1/3. That's right. The 3 turns into a 1/3. 1/3 times 2. No. 2 times 1/3. 2/3. And the last one we'll do is negative 2. If you put in a negative 2, right here. Remember, think of it as two things. It's squaring and it's flipping. 3 squared is 9. Flipped over is 1/9. 2 times 1/9. Remember, this is like a 2 over 1 times a 1/9. 2/9. All right, now that's 1, 2, 3, 4, 5 points. You wouldn't have had to have all 5 points, but you would have had a minimum 4. Okay, so in this 2, 18 is the one that's not going to fit on the graph. If anything's just barely off the graph, it's okay with me if you graph it. So like if you wanted to graph 12, that's just like a little off the graph, that's fine. 0, 2 goes through right here. 1, 6 over 1 up 6. Negative 1, 2/3. It's like about there. And negative 2, 2/9. Like there. So if I connect the dots, it basically looks like that. All right. So remember, 4 points is our minimum on these. We want you to have at least 4 points on your graph. That means you can't just have, okay, I know it goes through 1. In this case, it didn't even. Remember, this is the starting value on an exponential. Started at 2. They often go through 1, but then this one got stretched and got twice as tall, see? All right, if I'm going to graph this, XY chart, definitely. Telling you, it's way easier than trying to figure out where the thing is and trying to move it to the right and move it down and move it, you know, that kind of stuff. To me, it's way easier to make an XY chart. Now, what are some good numbers to pick? Be strategic. If I put in like 5, it'll actually shrink it down to 3. 5 minus 2 here makes 3, and 2 to the 3rd power is 8. And 8 minus 2 is 6. So 5 gives me 6. Those are numbers I can actually graph. If I put in, let's say, a 4 here. 4 minus 2. 4 minus 2 is 2. 2 to the 2nd is 4. 4 minus 2 is 2. 4, 2. Now let's go with 3. 3 minus 2 is 1. 2 to the 1st is 2. 2 minus 2 is 0. Now let's do 2. I put a 2 right here. 2 minus 2 is 0. 2 to the 0 is 1. 1 minus 2 is negative 1. Do I have at least 4 points? Yes, I do, and that's probably enough then. So 2, negative 1. Right there. And 3, 0. Right there. 4, 2. Right there. 5 comma 6. Right there. All right. If you really want, like, I'm not sure exactly where to, I think it's going to be kind of like this, but I'm not positive. Maybe I should just do one more point. Maybe I should go -1. Or sorry, x is 1. And see what I get. Put in a 1 here. 1 minus 2 is -1. 2 to the -1 is a half. And a half minus 2 is -1.5. Okay. So 1 goes with -1.5. Yeah, it's starting to level off there. So I think it's going to be pretty much like this. There we go. All right, I want to show you one more way just because I know some teachers are teaching it this way and I want to honor that. Some teachers are teaching it, graph the parent one, which always goes through 1, and then it goes over 1, and the parent one would be like 2 to the x. Okay? And then you'd put in a 1 and you'd have 2 to the 1 is 2. 1 comma 2. And then you'd put in a 2 and you'd have 2 to the second is 4. And you put in a 3 and you'd have 2 to the third is 8. And there's the parent one. The problem with this, my friends, is that you now have to move all of these points to the right 2, and then down 2. That's to the right 2. Then it's down 2. And the last thing is you got to make sure that you graph the right one in the first place. Okay, so basically, if I do this, I have to make all the points and then move all of them twice. Personally, I'd rather just find the right points in the first place and graph them once, and then just kind of look back and see, does this make sense? Compared to the parent one, this one's supposed to be stretched twice as tall. Oh yeah, this one's going up faster than the parent one, which would have been like this. So that makes sense to me. So I would rather not graph the parent and move it. I'd rather make an XY chart. So that's why I do it that way. Okay, I think that's all we need to know, other than these might get a little bit tough to do, but be strategic again. Try to find an XY when you have these on your homework. Trying to find an X and Y's that work nice. So don't just blindly put in numbers. Pick a number that's going to work nicely. Like if I put in a -4, the cool thing is this will turn into a 0, and anything to the 0 power is a 1. So this whole thing right there becomes a 1. Then 2 times the 1 makes 2. 2 minus 6 is -4. So I put in -4 and I got -4. That's a point. -4. 1, 2, 3, 4 right there. Now I can put in another point, but be strategic. I'd like this to turn into a 1 right here. So I need x to be -3. That'll make this a 1. Then I have 1/2 to the 1 is 1/2. 2 times a half is 1, and 1 minus 6 is -5. -3, -5. And I got to keep graphing points to figure out where the thing's curving. I don't know yet if it's curving like this, or if it's curving like that, or what it's doing until I get more points. You got to have at least 4. If you just think about it, do you know that this parent graph looks like this? I hope you know that. Because the parent is the 1/2 to the x, and that's a decay. And then it's been moved down 6, 4 to the left, and stretched twice as tall. Again, if you wanted to graph the parent points and then do all of that, you can do that. But I think it's going to be way more work than making the XY chart right off the bat. I really think the blend of both methods is the best. Graph it, find your points, and let's say it ends up looking like this, and then you just double check and say, does that make any sense? Which was the parent was like this, and then it gets moved down 6, well that's good, and then left 4, oh that's good, I was moving down and left at least, and then stretched up, okay, well then this one does look stretched a little bit, so yeah, it should look something like that. So it's good to kind of check yourself, but the XY chart is boss in my opinion. All right, move on to the application problem. It's light blue. We are almost done. Mr. Best bought a boombox in 1986 for $80. The boombox lost 17% of its value until now, and I think he meant every year until now. Make a set of axes and graph the value of the boombox from 1986 until 2000. Label your axes and be sure to include at least 2 points and a curve that matches the trend of the value. So basically, they want you to graph it with a couple points. Well, I'll tell you one thing. One point is that it started here in 1986 for $80. So that's one place I know is for sure is the start was worth $80. 80 bucks. I also know it's going down. So generally, do you get that the general picture of this graph looks like this? That's called decay. Now, if I had to write a formula for it, I'd go like this. Y equals AB to the X. And what is my starting value that I should put in for the A? That's where the starting number always goes. 80. And my B is one of these guys. Remember these? 1 plus or 1 minus. And what is this? 1 minus 0.17, yup, to the X. We just learned how to make those yesterday. Does that make sense? You better write this one down. It's a good example problem for yourself for later. That's the start value. There's your decay of 15%. Actually, wait a minute. Is it 17? Yeah, it is 17%. Decay of 17%. Okay. Now, how can I get my points for my XY chart? All it asks me for is 2 points. I just have to make any other point. The other graphs you had to make 5 points on, or 4 points. This, you only need 1 more point. Okay. You put in x equals 0, and guess what? That turns into a 1, and then it's 80. Already had that point. So it was a good idea, but, okay, 1. How about we do 1? If x is equal to 1, then this is 1 minus 0.17, and that's 0.83. 0.83 to the 1 power is 0.83. 0.83 times the 80, you'd be allowed to use the calculator to do one like that. 0.83 times 80. I mean, again, you could do this in your head, but thank you. That means at time 1, this is 66.4. There we go. I have one other point on my graph. All right, so here's some stuff you should know. What did I just graph? Growth or decay? Decay. That is called the what? Y-intercept. Also known as, in the context of a problem, the start value. And it's also where x equals 0. Very good. Okay, if you have to graph any other point, you can just pick an x value and stick it into your formula. And if you pick x to be like, 2 or something, then you figure out what y has to be from your formula. Your formulas always look like this. And this one's got a growth rate of not 3%, but 30%. That'd be a 30% growth rate and a start value of 5. All right, that's all I have for you. Your assignment is a worksheet, which I'd like to have you pull up, and I'll see if there's any I would want you to skip.